A sequence is simply a group of items that follows a particular order. Group of items or events or data whose next next term has a set of rules or patterns that links them together. For instance, you have 1, 3, 5. If I will ask, you have 1, 3, 5. The next term is likely to be, yes, I think you're correct, 7. Because you look at the way it's increasing. This is the first number. Next, we added 2. Next, we added 2. 2 was added. So if you look at this, we can actually predict more and more numbers as we wish. So if you have things like this, we refer to them as sequences. We could also have 100, 90, 80, 70, and so on. Look at this, you can actually predict the next numbers. 100 being the first term, the first number, 90, 80, 70. If I ask, what do you think the next number will be? Mere looking at the steps in which you get the next number from the previous, you notice that it shades of 10, or there's a subtraction here. From 100 to 90, we've removed 10. 90 to 80, we also removed 10. 80 to 70, we've removed 10, and so on. So 70, if you subtract 10 from 70, you have 60 as the next term. When you have things like, you can also have 1 square, 1, 2 square, 4, 3 square, 9, 4 square, 16, and so on. When you have all these numbers that follows themselves in a particular pattern, we refer to these as sequence. Now we have the first stage is the arithmetic sequences. Is a type of sequence. A type of sequence. Normally you see questions on arithmetic sequences in your checkpoint and little in IGCSE. Checkpoint and IG, but we're dealing with the first part, the foundational part. Now in arithmetic sequence, you only have a common first difference. What do I mean? For instance, if you have 3, 6, 9, 12, 15, and so on. We want to get the first difference. The first difference is the next term from the first minus, or you subtract the first from the next term. Subtract the first from the next term, like this. Let's use this. This is for the first difference. Okay, let me take this off. You have this, so let me remove this off. Take it off so that we can actually understand. Okay, we have this sequence. The first difference is you subtract them. 6 minus 3, you have plus 3. 9 minus 6 is plus 3. 12 minus 9 plus 3. 15 minus 12 plus 3. What we've just done, we've subtracted the previous from the next. This is the first difference. First difference. When the first difference is the same, is said to be an arithmetic or linear sequence. When the first difference is the same, is a linear or arithmetic sequence. Okay, let me put it here. Linear. Linear. When the first difference is the same. In this, we're going to look at we're going to look at the term to term rule. We're going to look at the term to term rule. Meanwhile, the first number you have is our first term. Some in IGCSE, in Checkpoint, Cambridge, first term we use U1, subscript 1. Second term, U subscript 2, U subscript 3, U subscript 4, and so on. We use this to actually note the different terms. This first term, the first number is U1. Some books use T1, T2, T3, depending, as long as we're saying the same thing. Okay, we'll go to the first subtopic, a first step, the subtopic under arithmetic sequence. Now let's look at this, the term to term rule. In the term to term rule, we try to look at what has happened to the previous term that it produces a next term, or what do you do to the previous term to get the next term. Now remember, like I said, you look at the difference, first difference. The first difference between them, these numbers, you have 12 minus 7 is positive 5, positive 5, positive 5, positive 5. So what is this telling me? It's telling me that for me to move from one term to another, I have to add positive 5. Like this, for me to get a U2, it must be U1 plus 5. U1 plus 5. 7 plus 5 is U2, which is 12. For me to get U3, it must be U2 plus 5. Now, what if I want to get that's the next term, will be UN plus 1, meaning 1 above n. It will be UN plus 5. So this is the term to term rule. This is the term to term rule. This is the term to term. I'm adding 5. So I'm adding 5 to the previous to get the next. This is the next, and this is the previous. I hope that sticks. The next is finding the nth term of a linear sequence. Finding the nth term of a linear sequence. Say we have 7, 9, 11, 13, and 15. Say we have this. We want to find the nth term. Now, the nth term is a rule that we can find any of the terms. A rule that we do not need a previous term to get the next term. Once we have that rule, we can get any of the terms. A function that helps us to find any of the terms. So look at this. We go to our first difference rule. Let's see. We have this quickly. 9 minus 7 plus 2, 11 minus 9 is plus 2, positive 2, 13 minus 11, positive 2, 15 minus 13, positive 2. It seems as the sequence continues, and we continue with the first difference, the plus 2 will continue to show up. Meaning, if you have n number of terms, 2 will appear n number of times. Because of that, we say 2 times n number of times. Now we'll ask ourselves, how do we start the sequence? If our sequence starts with 7, what would have been the number that would have appeared before 7 if 7 was not the first term? What I mean, if 7 was the second term, what would have been the first term, knowing that the common difference is plus 2? Easy. We say 7 you subtract plus 2 from 7. So it will be 7 minus 2, which is plus 5. So plus 5 would have appeared before 7. So it will give us a foundation. So the nth term of this sequence, or Tn, let's use Tn or Un as we've been using, Un of this sequence, to get any term of this sequence is 2n plus 5. 2n plus 5. We can get any of the sequences that is given. For instance, if we make n to be 1, 2 times 1, 2, 2 plus 5, 7, first term. If we make it 3, 2 times 3, 6, 6 plus 5, 11, the third term. Let's see another example. Now let's find the nth term of this. First thing we do, we get the common difference or the first difference. So we have, this is what we have, such that 9 minus 12 is negative 3, 6 minus 9 is negative 3, 3 minus 6 is negative 3, 0 minus 3 is negative 3. So the first difference is negative 3. It means that you have negative 3 n number of times, meaning negative 3 times n. Then let's ask ourselves, if 12 was not the first term, if 12 was a term after the first term, what would be our first term? We just say, because we're subtracting from 3, that number that we're looking for minus 3 equal to 12. That number we're looking for, say we're looking for P. P minus 3 is equal to 12. So P is equal to 12 plus 3, which is 15. So the number we're looking for is positive 15. So we put plus 15 here. So the nth term is negative 3n plus 15. Or you can also write it this way as 15 minus 3n. This is the nth term of the sequence. That is the nth term of the sequence. The nth term of the sequence. Now, I want us to look at this question. This is a checkpoint question. This is a checkpoint question on linear sequence. That's a junior high school question. Now, look at this. The nth term is 3n. I want you to get the nth term for the second and the third. Put it in the comment section. Now we have this question. It says the nth term of a sequence is given by the formula n plus 15 over 2n. Work out the first three terms of this sequence. This is a checkpoint question, 2015, paper 2. Okay, let's see. Let's get the first term. To get the first term, term 1 will be, we'll make n to equal, n will equal to 1. So it becomes 1 plus 15 over 2 times 1. So you have 16 over 2, which is 8. The first term is 8. Let's see the second term, term 2. Term 2, you make n equals 2. So this is 2 plus 15 over 2 times 2. This gives us 17 over 4, which is 4 whole number 1 over 4. I think we can get the third term. The third term should not be a problem. So I'll say term 3 will give 3 plus 15 over 2 times 3, which is 18 over 6, which gives us 3. So the third term is 3. Now we go higher to quadratic sequence. Quadratic sequence. In linear sequence, we dealt with something like this. A n plus b. This is for linear sequence. Let me put it under it. Linear sequence. We arrive at something like this. But for quadratic sequence, we're going to have something like this. No, we used u, so let's just maintain what we used. You have something like this. an squared plus bn plus c. The power of n is the power of n is 2. Power of n is 2. Now for us to actually grasp this, let's see how to come about or how to identify quadratic sequence. How to identify quadratic sequence. Okay, we'll start this way. We have 0, example, 0, 7, 18, 33, 52. Okay, let's see if this is a quadratic sequence. Now, for this part, you have students sitting for IGCSE and IB, seeing questions like this. I don't think you have checkpoints bringing out questions like this. So students that are preparing for checkpoint, I don't think this is for you. Now, okay, we'll go to the first difference. First difference, 7 minus 0 is plus 7. This is plus 11. 18 minus 7, 11. 33 minus 18 I think 15. I guess 15. 52 minus 33 are 19 plus 19 plus 19 like this. Okay, plus 19. That's it. You notice for the first difference, we don't have same numbers. We try it again. Second difference. So 11 minus 7, 4. 15 minus 11, 4. Aha. 19 minus 15, 4. So the second difference gives us a common value. Hence, it tells us it is a quadratic sequence. It tells us, is a proof that this is a quadratic sequence. It is a quadratic sequence. Hence, how do we solve quadratic sequences? It's easy. First, we'll make n 1. First, let's try the first term. Let's try the first term. Sorry, I'm going to clean this. I'm going to take this off. Start solving here because of our space. 1. N is 1. If n is 1, you have a plus b plus c when n is 1. Okay, I'll move this a little. When n is 1. When n is 2, we have 2 squares 4, 4a plus 2b plus c when n is 2. When n is 2. Now, when n is 3, you have 9a plus 3b plus c when n is 3. Now, I want to build a concept. Let's see, can we get the first difference here? We want to get the first difference here. The first difference here will be 3a, 4a minus a is 3a, 2b minus b is b, c minus c is 0. Let's see the same thing here. 9a minus 4a is 5a, 3b minus 2b is b, c minus c is 0. This is the first difference. Let's create the second difference because we know it's quadratic, so it should stop in the second difference. 5a minus 3a is 2a, b minus b is 0. So the constant term must be equal to 2a. So we can get the value of a. We can get the value of a. So this will be, let's see, the value of a from what we have will be, for second difference will be 2a. The first difference will be 3a plus b. And the initial first term will be a plus b plus c. A plus b plus c. So we now want to solve what we have. Okay, let's continue. For the second common number, second difference, the common number we have in the second difference is 4a. here, sorry, is 4 plus 4, and we know it is equal to 2a, what we have there. So it means 2a equal to 4. Hence, a is equal to 2. Let's go to the second one. We're done with this. We go to the next one. It means 3a plus b is equal to plus 7. So 3a plus b is equal to 7. And we know a is 2. So 3 times 2 times 2 plus b equal to 7. Hence, b is equal to 7 minus 6. b equal to 1. We've gotten the value of b. Now let's get the value of c. The value of c will be from the first one, first term is 0 and equals to that. It means that a plus b plus c equal to 0. Now we have a to be 2 plus b as 1 plus c equal to 0. So we have 3 plus c equal to 0 and c, okay, let's put it down here. Let me put it down. Hence, c equal to negative 3. C is negative 3. Sorry, it is scattered, but I believe we'll have a better arrangement next time. So let's see. I have from the general equation, it is un equal to an square plus bn plus c. Since we know what a, b, and c are, we can say un equal to a is 2, 2n square, b is 1 plus n, and c is negative 3 minus 3. So this is the nth term of this sequence. We can try it if it gives us the same result. If n is 1, 1 square is 1, 1 times 2 is 2, 2 plus 1, 3, 3 minus 3 is 0, correct, for first term. Let's see for second term, 2 square is 4, 4 plus 2, 4 times 2, sorry, is 8, 8 plus 2 is 10, 10 minus 3 is 7. So I think that's the answer. But I just want us to take something back, that for this, the second difference is 2a. Second difference 2a, as second difference is this 2a. First difference 3a plus b, and the first term is a plus b plus c. Wow. So in the next example, it's going to be a lot shorter. It's going to be a lot shorter. Okay, let's see. Okay, to buttress this point better, we have another question. Find the nth term of the sequence 2, 5, 10, 17, 26. So what we do is to get the differences. Okay, just remember this, that the second difference must equal to this if it is the same. First difference 3a plus b, and the term 1 is a plus b plus c. They will now fix it here. Okay, so you have 2, 5, 10, 17, and 26. Now we want to start breaking them to their differences. Now, look at first difference. This is 3. 5 minus 2, 3. 10 minus 5, 5. 17 minus 10, 7. 26 minus 17, 9. First difference, 2. So, we've gotten the second difference to be 2. Now we apply it. We know second difference, if it's 2, it means second difference 2a equal to 2. Hence, a is equal to 1. First difference. We're done with this. First difference now. 3a plus b equal to 3. And we know a is 1. So, 3 plus b equals to 3. Remember, this is, okay, 3 times 1, so you will not be confused. So, this is 3 plus b equals to 3. So, b is equals to 3 minus 3. So, b is 0. B is 0. Now, let's see for c. We know for the first term, we know a plus b plus c should equal to 2. So, a plus b plus c equal to 2. And a is 1, b is 0, c here. So, this is c equals to 2 minus 1. I guess you understand. So, c equal to 1. Now, let's write this following what we have. Let's rewrite it following what we have. The formula will now becomes un equal to an square, but a is 1, so it's just n square plus b is 0, 0b, so b will not be there, and c is 1. So this is the nth term of our sequence. That is the nth term of the sequence. Remember, b is 0, so 0 times n is 0, so we don't put it there. So we have n square equal to 1. N square equal to 1. Similar step or approach goes to cubic sequences. Cubic sequences. I think this is a way of helping out. You can go further. For more information, my number is there. You give me a call. I can put you through. Thank you.